Okay, good morning. This is Professor David J. De Los Reyes. Okay, my topic for this morning will be a continuation of my subject matter trigonometry, and I am now, or we are now on lesson number 3. Okay, let's proceed. Our lesson for tonight will be trigonometry, or for this morning, trigonometry lesson number 3. And the title of the topic will be Example Problem on Latitude. Latitude, it involves angle. Okay, I will try to read the problem so we could visualize what will be the solution of the required problem. A town in Luzon is with a latitude of north 18 degrees 28 minutes 32 seconds. Assuming that the Earth to be a sphere, of which the radius is 3960 miles, 3,960 miles, find the distance of the equator to the town. Oh, it's a little bit complicated if you do not know how to define what is latitude. So before we could solve the problem, let's try to define first what is latitude. This is now actually with regards to the distance around the Earth. Okay, by definition, latitude is the angular distance of a point on the surface of the Earth from the equator, and is either to the north or to the south. Latitude is something like this. If this is our Earth, it looks like a watermelon, right? So this should be the skirt of the Earth. This is the other side of the skirt, on the other side. To plot a latitude will be something like this. This is a latitude. Okay, it seems we are given a wire that is around the watermelon. Okay, and we try to move. This will be the pivot point. If we try to pivot the what do you call this latitude, the range should be from the equator going up or the equator going down. So according to the definition, latitude is the angular distance of a point on the surface of the Earth from the equator, and is either north or south. So it is something like this. We'll try to connect this curve here. Okay, so the latitude of the town is this one. Okay, and the location of the town will be this. Okay, so if this is the center of the Earth, and the distance from the center of the Earth to the equator is actually represented by radius r. Actually, the radius of the Earth is not so much. It's only around 3960 miles. Right? 3960. Okay? And the given latitude with respect to the equator is actually given by this angle theta here. And this angle theta is, what do you call this, 18 degrees. Theta is 18 degrees, okay, 28 minutes, 32 seconds. So with respect to the equator, okay, the town is actually, the latitude is actually north, right? So the angle should go up from the equator to the North Pole, right? Okay? But this was the location of the town. It's not here. It could be here, maybe. It depends. It could be here, or it could be at the North Pole, right? So if you try to see it, okay, there are different angles that will be coming out. And according to the given problem, the latitude, okay, as the latitude moves from the equator going to the North Pole, because this is north, okay, north 18 degrees 28 minutes, right? The angle is only a small one, okay? It is theta is equal to 18 degrees 28 minutes 22 seconds. So meaning to say the town is actually very near the equator. Okay, the solution of the problem is just a simple one, but to visualize it, okay, we must have to visualize it, right? So with respect to the equator, if you try to rotate this line here going up, that theta is actually the latitude. And the latitude of the given town is actually north, meaning north, it goes to the North Pole, going up, right? It's not going down. Because if it is south, it should be going down, right? The value of theta is actually 18 degrees, 28 minutes, 32 seconds. Because the maximum value of theta is actually 90 degrees. Where is the town if the value of theta is 90 degrees? It is at the North Pole. Theta will be 90 degrees, right? But if theta is only around 18 degrees, the location in the town is just very near the equator. This is the equator, right? So this is the center of the earth. Oh, that's how we plot a latitude. From the center of the earth, okay, this is, what you call this, coincide with the equator, then it goes up. Latitude goes up from 0 to 18 degrees, to 30 degrees, 60 degrees, maybe 85 degrees. Then if the town is at the location North Pole, the value of theta will be 90 degrees. So the maximum value of theta is actually 90 degrees. But the given latitude of the town is just only 18 degrees, 28 minutes, 32 seconds. So the town is just actually very near the equator. Okay? And the problem is asking, find the distance of the equator from the town. The distance of the town, if this is the town, this arc here, it seems we are given an arc, it is something like this. This is S, and this will be theta, and this is R. Okay, this is the center of the earth. Okay, this is the equator, and this is the town, right? So the distance of the equator from the town is actually S. It is this arc here. Okay, and we are given the latitude of the town with respect to the equator. It is only around 18 degrees, 28 minutes, 32 seconds. So this is a simple problem, but the problem is how to visualize it. At least we know how to plot a latitude on the, what you call this, globe system of the earth, right? So this is the center of the earth, this is the equator, okay? This is the town, and according to the problem, the latitude, okay, it starts with 0, it rotates a lot, only around 18 degrees, 28 minutes, 32 seconds. And the problem is just asking what will be S. S is actually the distance between the town and the equator. It's a curve. Okay? So if we try to bring out the solution of this one, like what I said, okay, this should be the town, this is the equator, and the given latitude is theta is equal to 18 degrees, 28 minutes, 32 seconds. And the problem is just asking what will be the distance between the equator and the town. It is S. So we will be using the formula S is equal to R theta. Okay, we will be using this one. And the relevance of this to our previous topic is actually it involves angle. Okay, so actually we are given R. R is actually the radius of the earth. It is 3960 miles. It's not so much, right? 3960 miles. Okay, we are given the radius of the earth. We are given the theta. Theta is actually the given latitude. Okay, the given latitude. It is 18 degrees, 28 minutes, 32 seconds. Okay, let's now try to compute for the value of S. But before we could compute for the value of S, we must have to convert this theta here to radians, okay? Because in this formula, theta should be in radians, right? But there should be a little problem because this is degree, this is minutes, and this is seconds. And to convert it to radians, it's a little bit, we add up some parts, right? So we'll just maintain 18 degrees. Am I still on camera? Okay, 18 degrees. And we will convert this 28 minutes to degrees. We know that 1 degree is 60 minutes, right? So we convert this minutes to degree, we will divide this by 60. Okay, and if we try to convert seconds to minutes, no, degrees again, we will multiply or we will divide this 32 by 62 times. Actually, this is 32 over 60 times 1 over 60 again. Because 32 over 60, it will become minutes, right? Okay, minutes. So if we will divide it again by 60, it will now become degrees. Okay, so this is 1 over 60, or that is 32 over 3600. This is 0.467, this is 0.0089. The total summation of this, in terms of degrees, is 18.475 degrees. Okay, converting this to radians, it will be relation number 2, the relationship of radians to degrees. That is 1 complete revolution is 2 per radians, or that is actually equivalent to 360 degrees. So this degree here cancel with this. So multiplying this one divided by 60, it will become 0.322 radians. Meaning to say the latitude of the town, the angle of inclination of the town with respect to the equator is only around 0.322 radians. Okay, it seems this is the horizontal line. We rotate this line, it coincides with this. Okay, and when the angle is 18 degrees, 28 minutes, 32 seconds, that's the location of the town. Right? That's the location of the town. So by using the formula S equal to R theta now, we are given the radius of the Earth. Okay, this miles times 0.322 radians. Okay, what comes out is 1276.9 miles. The distance of the town with respect to the equator is only around 1,276 miles. The angle is very small, right? So if this is a horizontal line, we rotate this one up to 18 degrees. So actually the town is very near the equator. The angle of inclination, called the latitude, is only around 18 degrees, 28 minutes, 32 seconds. Okay, that's it, guys. That is an application of angular measurements. Okay, this is now what they call this. This is an actual problem. Because if you try to locate a certain point on the Earth, we must have to specify its latitude and longitude. And actually, that's a very dangerous one. Why it's very dangerous? The the concept of this one is actually the design of the so-called intercontinental ballistic missile, right? Because right? Because if they know your latitude and they know your longitude, this is your latitude, this is your longitude, right? They could pinpoint your exact location on the Earth, right? So if somebody tries to target you, that's a very easy one, right? They just if they know your exact latitude and longitude, they could target you anytime. Okay, good morning from Los Angeles. This is Professor David J.